In the last video, we talked about hard-coding attributes in our select.xml template. Now let's take a look at how we can start to make those attributes dynamic. Back in hello-world.xml, we've hard-coded hello world in the print tag, so executing that file returns hello world in my browser. But now let's turn this into a script. To do that, we put curly braces at the beginning and end. And now this value in the middle is a string, so I have to quote that. So I've got a script, and inside that script a single string. So for now it will return the same thing. But if instead of a string I put an identifier, let's say message, I'll get a blank screen because the identifier message hasn't been assigned. But now I can assign a value at the end of the URL. Message equals, and whatever I assign shows up in the browser. Now I'll apply the same concept to my select.xml template. So instead of hard-coding a filter for year, for example, I'll change the filter column to a script and add an identifier. I'll use year, same as the column name, to make it simple. Now if I run select.xml and don't specify a year, I will get all of the years by default. But if I specify a value for the year filter script in the URL, for example, year equals 2007, I get only 2007 records. And I can use lists here just like we did in the last video when we were hard-coding values. So this returns records for 2005 through 2007. And I can do this on all of my columns, month, type, and so on. So now at the URL, I can add month equals 10 and type equals zoning star. So you quickly see how we've shifted this template from static to dynamic by plugging in these expressions, these scripts at the column level. We've moved our query tool to the URL. So this is the starting point of this idea of URLs for data. I've been naming these scripts based on the column names, and this is so common that I can actually go up to the XLS tag and choose autofilter equals Y, and this automatically assigns a filter to each column using a script based on the name of the column. So now select.xml works the same way as if I had added a script filter to each and every column. So now I have complete control over the dataset via the URL just by adding this autofilter attribute. I can filter by any column name. I can apply the exact same concept to the select attribute. If I set autoselect equals Y on the XLS tag, it's the same as if I added a select equals script to each column, just like we did with filter. So now I have control over the column selection with the URL. For example, I'll add select equals type, subtype, year, and I only get those columns returned. Land use category also shows up because we have a column attribute set to sort by that column. And we could do the same thing with the sort attribute. So I just add auto sort equals Y at the XLS tag level, and now I have control of sorting through the URL as well. So now we've quickly moved from static, hard-coding the select, filter, and sort attributes at the column tag level, to dynamic, using attribute scripts at the column level to move control over the dataset to the URL. Then we use the autoselect, autofilter, autosort attributes at the next level up, the XLS tag, which essentially gives us a shortcut so that we don't have to create select, filter, and sort scripts on every single column tag. This represents the basic programming foundation for the URLs for data methodology. And as we move forward, we will quickly see how this incredibly efficient design concept gives power users and entry-level developers tools to create an extremely powerful search engine for data. Thanks for watching.